Hi guys, welcome back, and we've got a really exciting game lined up today. We are going to be doing a game called a Robot Hunter. It's a 2D shooter that works on an infinite background, which means we're going to learn how to scroll a background so that you can start walking in any direction as much as you want to. This takes some tricky math, so there's some stuff here that you're going to have some difficulty understanding, especially if you're in our target age group, like 8 or 9 years old. This is really high school math. Don't sweat the math, though. You'll be able to reset this game and get some really cool stuff going if you remix it yourself. And just grab the math code and just use it. You don't have to understand it to use it, guys. Okay, so let's get started here. So here's our game screen, and you can see we've got a bunch of sprites already set up. I've done most of the work for you in the starter file here. You'll see some blocks of code that are some complicated math, as I was saying. Here's an example. I frankly am having some trouble understanding this code too, so my son Jeffrey set this up, and so there's some functions in here that have to do with square roots and stuff called trigonometry, which is the study of triangles. There's stuff like cosines and sines and stuff like that in there. I'm not a huge high school math fan. I understand elementary school math perfectly. I teach it all the time. But this stuff that we get into in trigonometry is a little bit past my level, so I certainly don't expect you to understand it. Okay, so we've got some sprites here on the side. We've got our astronaut who's going to be running around the map. We've got our evil robots, and I can show you their graphics if you like. So I've designed a bunch of these robots that look like this. They are animated. There's a lot of costumes in them, right? The costumes are all going to show them kind of waving their hands in the air. This started off as a zombie game, and I kind of reskinned it. So I used the animations of the zombies walking, and that's how we got these things. I basically traced over all the images with a new robot picture, and that's what we're using here. We've got a laser sprite that I call a bullet, and we've got a whole bunch of ground tiles that look like this thing down here, and we're going to be using a flashlight. This whole game's going to be set in the dark, so we're going to be using a flashlight to hide what happens inside the game. Let me show you what that's going to look like. So there's a couple of sprites that I've hidden here, and once they're all connected, you're going to see that the only part of the game that you're going to be able to see is up front where you're shining the flashlight. That's going to make it extra creepy, I think. But it's a tricky game. Like if you're not constantly moving forward, stuff is going to get you from behind, and you're not even going to know it until you're dead. I don't have any lives set up in this game right now. You just get one chance, but you could modify it pretty easily to get lives in there. Okay, so let's start some coding here, guys. All right. Astronaut is what we're going to start on, so let's get on to him. As I said before, ignore this code that has a little bit of math in it. I'm going to explain that in a couple of minutes, but for now, let's just get out our green flag, which is usually how we start these projects. So under events, I'm going to go to when green flag clicked. Let's blow that up a little bit because it's a bit too small to see on the screen. Okay, so the first thing we're going to do with our astronaut is set him to the middle of the screen. He's going to stay on the middle of the screen the whole game. So because this is an infinite scroller, the world is going to move around us. We're always going to be in the middle of the map, no matter where we go. And so because of that, we have to kind of create a virtual game board that's huge. So our X and Y coordinates, we're going to have the typical X, Y coordinates that tell you where you are on the screen, but they're always going to be 0. So we're going to change another variable that's going to be player X and player Y, and that's going to be our position in this gigantic world that we're creating. So in Scratch, you can only go 480 pixels left or right, or 360 pixels up or down, but this is going to let us go thousands of pixels over right off the screen, right? Because we're stuck in the middle, this virtual screen can be as big as we want it to be. So, but we're always going to be planted in the middle of it. So let's start in the middle of this invisible screen. We've got to change some variables to do that. Let's go to our variables, and we're going to go set a variable. And we have a couple of preset variables in our starter file here. So the one is called player X. Player X, yeah, and we're setting that to 0. I'm just going to duplicate that to save some time. And then let's go player Y. So that's setting us to the middle of this big invisible map. Okay, now we're going to be, the controls we're going to be using are WASD, which you're going to have in your left hand, and in your right hand you're going to be using the mouse to maneuver around. So you're going to be pointing in which direction you want to go with the mouse, in which direction you want to face, but you'll be able to walk backwards, basically. So if I point my mouse in this direction but hit the S button, I will still keep facing my enemy but walking backwards. So it's a little bit tricky to get used to at first. It would work much better with a game controller, frankly, but we're in Scratch here, which uses keyboard input, so we'll do the best we can. So WASD to move around, and then mouse to look around. And so if you want to go down, moving your mouse around isn't going to help. You're going to have to hit the S key and then point in the direction you want to look. Okay, so let's grab a forever. So we'll go to our control blocks, and we will grab a little forever block, which looks like this. And that will tell everything inside here to repeat over and over again. So we're just going to go through this cycle of repositioning our guide based on what our keyboard inputs are. Okay, so the first thing we need to do is we have some more variables. So now that we've set our first XY variable for our players, we need to have a variable saying how far the player has moved. And we're really just checking to see has he moved left, right, or up or down. And that's going to be stored in a variable, one for the X coordinate and one for the Y coordinate. So it's called player X change. So let's go and grab another variable changing block here, which is called set variable. So we're going to set a variable, and the first variable we're going to get is player X change, and that's set to 0. And then player Y change is also set to 0. So we're just telling it at the very beginning to recenter the graphic on where your player is, and then we'll slide the world over depending on where you went. So we're staying still. Player X change, which it should be, and then player Y change. And so every turn we're going to reset this back to 0 again, and we'll see how far over we slide in which direction, and that's going to affect the rest of the world, these ground blocks that we're talking about. Okay, so now let's get our keyboard input. First we have to do a point in direction. So we have to tell our character to face wherever our mouse is facing, and we're going to do that in our motion blocks here, just by saying point towards mouse pointer. And so no matter where we move our mouse, he's going to rotate to point towards the mouse pointer. Okay, now we can do our keyboard inputs. I'm going to have to move this other block out of the way. There we go. Let's stop this. I don't know how it got running. Okay, so we'll start with an if statement. And that's how we usually do keyboard inputs. We check and see if that button's been pressed. So I'm going to grab an if, and I'm going to say if key W pressed. So we go to our sensing commands, the light blue ones, and there's a command in there that says key space pressed, and we can modify that to whatever we want. So I'm going to go key W. So when I hit the W key on my keyboard, what are we going to do? So we're not going to move. We're just going to keep track of the fact that we hit that button by changing our Y coordinate by 1. So we're going to change that variable player Y change, and we're going to change it by 1. So let's go into our variables, and we'll go change variable, change player Y change. Okay, so we're basically telling it that we are moving in the up direction. If we hit 2 keys, if we went W and D, for example, then the Y would change and the X would change, right? And so we're just keeping track of these numbers, and then we'll process them later and do something with it. Now I want to do 3 more if statements, so they're just variations on this, so I don't have to redrag the blocks out of there. I'm just going to right click on the word if, and that's going to grab everything inside this if statement and make a copy of it. Remember, if you're on a Chromebook, you can go with 2 fingers down on the keypad like this, and that'll give you your right clicker that you don't normally have on a Chromebook. Okay, let's go here, right click, duplicate. I'm actually going to go ahead and make all 4 of them right now. Make sure they're stacked up on top of each other. Oh, you see I accidentally dropped that one in the wrong place. Be super careful about that. And we'll do the last one. So remember, it doesn't let go until you actually click. So make sure it's in the right place before you commit by clicking. So I can see now it'll land in the proper location. So we're good. Excellent. So let's change these keyboard inputs now. So let's change this first one to WS. So we're going up, then down. And then the third one is going to be an A. And the fourth one's going to be a D. So let's just change those letters first. A. And then D. And so this now we're going back to the one that's marked letter S. We're also going to change player Y here because we're moving down. So we're going to go -1 here. -1. And then we're going to go if key A is pressed, then we're going to change our X. So let's just change our player X change by 1. And with the next one here, we're going to go player player X change by -1. So when we're moving to the left, we're going to go -1 on that. Okay. Now there's a few more blocks to do here, about 5 more blocks. So just bear with me, and we'll be done in a second. I'm going to save my working file, so for those of you looking on YouTube, so that you can refresh with what we have right now. Okay. Now, here's where we're going to do some weird math stuff. I'm going to do something called normalizing. Actually, I'm going to take a break right now and take some questions from my audience, and I will be right back. Okay, guys, so we're going to do something called normalizing our vectors now, and that sounds really, really complicated. I've got a little diagram ready here that's going to explain this to you, and it'll all make a little more sense. Alright, here we are in Scratch. We've got our little math screen. Let's see if I can, I don't know if I zoom it in, then it'll be kind of shaky, eh? Alright, yeah, so I'm not going to. So imagine that the purple dot is your character inside the game, and we're trying to move him in different directions, okay? So if I want to move him to the right, I change my X coordinate by 5. So he moves at a speed of 5 in this game, right? So he goes 1, 2, 3, 4, 5, and he does that beautifully. If I tell him to go up, he goes 1, 2, 3, 4, 5, and he will move up beautifully, and then at the same distance. But if I hit both my W key and my D key, I'm going to tell him to move on a diagonal, which is going to move him 1, 2, 3, 4, 5. Now, some of you guys who play a lot of these 2D shooters and stuff, and even this also applies to 3D shooters as well, are going to notice something weird here, which is that your character's not going to move the proper distance. Check this out. So when I grab this block here and I turn it on the diagonal, you're going to see that it doesn't reach my character. That is because of Pythagoras, who some of you guys might know from math, right? So the idea behind Pythagoras' theorem is that this, let me undo that and get my thing back here again. So this line here is always longer than these two. It's a very strict relationship. The length of this line this is a right angle triangle. The length of this line is always different from this line, and they're related to each other. You can do some math. A squared plus B squared equals C squared. That will get you the length of that. So the reason that we need to be careful of that in a video game is when we move on that diagonal, we can actually cheat. We can walk farther than 5 steps. We're actually walking like a little, like 6.3 or 6.4 steps or something like that. And so some very smart players in 3D shooters have been doing that for years, going on angles to try and speed up their movement. So if you, in some of the older video games in particular, if you keep strafing on an angle like this as you move across the screen, you'll find it superpowers your speed. And so if someone's chasing you and they don't know this trick, you can actually use it to catch up with people or get away from enemies, which is kind of cool. So that's not the way it's supposed to be, and so we have to do some tricky math to make it so that the character actually moves the length of that line. So we need to set this up so that every time we move, our character is going to move this distance, not this distance. Does that make sense, guys? Okay, so let's go and do the code here. So Jeffrey has already gone ahead and, oh, I'm in the wrong file here. So let's get back to my robot game. All right, so Jeffrey has already included the code for doing that. So the process is called normalizing, and there's just a whole bunch of math involved here, and we don't really need to understand what it is, but it's basically we're taking Pythagoras' theorem and implementing it here so that we can figure out what the actual distance away should be rather than the distance that it's telling you to go, which is going to be too long. So whenever we go on a diagonal, we want to make sure that we normalize that figure. Okay, so we have this function here. So a function is a custom block that you guys have created, and it's called normalize. We can drop that in here now, right underneath the if statements. Tell it to normalize. And what are we going to normalize? Well, we're going to normalize the amount that we're changing so that no matter what angle we're moving at, it'll always be the same distance on the screen. Not the same number of squares, but the same distance, because when you're on an angle, the distance is always longer. Okay, that's the last thing I'm going to say about normalizing, guys. So let's put our variables in there, which are player X change and player Y change. So we'll put player X change in the first spot and player Y change in the second spot. Now this is just going to do some magic, and it's going to return a number that will tell us the actual location that player X and player Y should, that your X coordinate and your Y coordinate should be if you're moving on an angle, and that will slow you down so that you can't cheat by going on a diagonal. Okay, so we're going to take those variables that come out of it and tell it to put that into our movement. So the movement that we're getting right now is only a movement of 1. We have to multiply that by 5 so that we're actually moving at a speed of 5 across the screen. So just bear with me here. We're going to grab a change variable block. We're going to drop it in here. This is about as complicated as any game that we're going to do here is going to get. I'm going to go back to some simpler stuff after this, guys. You guys keep asking me for some really hard games, and I'm happy to accept the challenge, but I think some of you are going, oh, why did we ask Mr. T to do this hard game? All right, bear with me, guys. This is going to be fun. Okay, so we're going to change our player X by, so let's change player X change, which is that variable, by, we need a multiplication symbol in here because we're going to multiply it by 5. So we're going to take the output of that function, the information that came out of it, we're going to put it in here, and then we're going to multiply it by 5. So the first stat we're looking for is called X out, and that's the new X coordinate that it gave you after running it through the fabulous machine here. So there's a little bubble in here under variables called X out. And we're going to multiply that by 5. Now we're going to do something very similar underneath. So I'm just going to duplicate this block again. We'll change it to player Y change. And we'll remove this X out bubble and replace it with a Y out. There we go. Okay, now we're good to go. 2 more blocks and then I will save my file so you guys can share it on YouTube. Alright, so now that we've changed all these variables, we need to actually move our player. So we're going to change our player X now. So now that we've done all the math, we can actually move our player. Remember, we're not moving the player but the world, but this is telling us how far our player has moved in the world. So we're going to change player X by the amount that it's changed. So that's player X change. So change it by that amount. And then let's grab another change. And that one's going to be change player Y by, and that one's going to be player Y change. So we're just changing it by the amount that he's moved in. So all of this complicated code, all it has really done is told us if we move up, how far do we have to move to go up. But we had to do some fairly complex math to do that. Now we can plug that all into our ground sprite. So we're good to go here with the astronaut for now, and in a second we'll just go over to the ground sprite and start looking at that. Again, there's not much to see here in the game yet. So let me save my file, and now let's maximize it and start playing. You can't really play it. All you can do is spin around. So the only block that's actually doing anything in the game right now is the point towards player button, and that will get us pointing in the right direction, but not moving because we have to go over to our ground and figure out how to move that. So let's go over and do that right now. Okay, guys, So we've got a little bit more math to do again. I'm going to teach you about a function that we've never used before in Scratch called mod. And it's a little bit complex, but it's super helpful when you get into scrolling games like this one. We might be doing another simpler 2D scrolling game next week, and we're going to be using the mod command for that. Again, if you don't understand this stuff, no big deal, but we'll be using this function. I at least want you to have an overview of how it works, even if it doesn't quite, if the math doesn't totally make sense to you. So let's get to it. Alright, we're here on my game screen. I'm going to zoom in on this stuff happening down the bottom. So I included these blocks here in the file. They're not actually part of the game file. They're just some blocks that I dropped in here to show you something. So I'm going to unplug this first one here, and I'll make my variables visible. So I've got a variable called test and test2. So let's blow this up a bit. Okay, so test2 is running right now, and watch what happens with it. All it does is it counts from 1 to 10. So it's setting that variable to 0, and it changes it by 1. So it's counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When it gets to 10, I'm telling it, if you get to 10, set the variable back to 0, and then you can start counting again. So it's just an infinite counter that counts from 1 to 10. Alright, so that's really cool, but there's a simpler way to do it in Scratch, and that's using this function called mod. Mod is can be found inside the operators, and it's down here at the bottom. It's a strange function. It basically is a math function that will give you the remainder in a division operation. So if I go 6 divided by 5, the answer is 1, but there's a remainder of 1. So the mod from that, that would come out of that would be 1. So if I go 7 divided by 5, that's still 1, but the remainder is 2. And so the mod of that number would be 2. Why is that useful? It's useful for stuff like this where you're repeating something over and over again. Let's say you have a number that's incrementing, going up and up and up and up in your program, but once it reaches a certain level, you want it to go down to the bottom again. You can use if statements for that, but the much more elegant way is using this mod command. So let me show you what the same function looks like with the mod in it. So we're taking, instead of an if statement, we're saying take that number that we just changed by 1 and tell us what the mod is of it. So we're going to drag that number through this mod function, then tell us what the equation is. And whatever that number is we put in the mod is the maximum number we're going to be able to get to. So when I plug this back in again, you're going to see that our variable test, which is the one with the mod attached, is doing the exact same thing as test2. And so the cool thing is now I can change this around just by changing this number. So if I want to count to 20, for example, I can enter 20 in the mod here. And now test is going all the way up to 20 before it recycles itself. Now, how does that apply to this game? I'm just going to trash these things for starters. Let's get rid of those variables and hide them off our screen. Like so. And like so. And we can just trash this stuff because it's not really part of the game. I just wanted to demonstrate it to you guys. Alright. Oh, there's one more somewhere. Where did it go? Let's go clean up blocks. I don't know if you guys know about that function. If you got stuff all over the place and you want to tidy it up, just go clean up blocks. Oh, I must have trashed both of them without realizing it. Okay, anyway, so if you got stuff kind of lying around everywhere and you want to tidy it up, just go clean up blocks with a right click, and it will bring everything into a nice vertical stack where you can start finding it. You can lose stuff here on this pasteboard here with Scratch, and so it helps to be able to do that. So I've got a bunch of code here. I've duplicated this ground 4 times, and I've hidden it for most of the other sprites except for this one here, just so that I can show you what's happening. I'm going to take my flashlight and I'm going to hide both of these graphics so that I can see my ground without any interruption. There we go. So now here's my repeating background that I'm going to be using. Now let's go back to the first one. I have, as I said, already taken the liberty of changing that, of doing this coding for you. So to get it running, you just have to attach it in here. And then let's click the green flag and see what happens. So this is only part of the process here. Let's hit W to start moving up. And And so I'm going to point up, and it doesn't matter where I'm pointing because it's a keyboard command. So you see, as I move up, the world starts to move towards me, right? And that's going to create the illusion that we're walking. It only moves in the one, well, no, we can move left, right, up, down. Okay, but you notice something weird happens here. When I move it too far, it resets itself and moves right back to the top again. So let me keep hitting the S key to move down here. Let's move it down, 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 down. And when it reaches a certain threshold, watch what happens. When it gets right to the top, it resets itself again. That's the mod in action. It's telling it when I get past when my coordinates of the screen here get past 480, they go back down to 1 again, just like my counter when it got to 20 went back to 1 again. So this function is basically telling it keep scrolling, and when you get to the end, reset yourself so that you can keep going across the screen. So we have an infinite number of these things going across the screen, but there's a problem, right? There's all this messy stuff around. No matter what you do or how you move, unless you are perfectly centered on the screen, you're always going to have these white boundaries around here. One on the left here, one on the bottom, or if I move in the other direction, you'll see that the white boundary will be on the other side. So, actually it's not, eh? So we're always putting it on the left. Anyway, so the way we fix that is we lay down a couple of other ones. We've got 4 of the ground tiles, and every single one of them is offset in a different direction. So let's hide this one right now, just so that I can show you how the second one works. So I'm going to hide that, and let's go over to ground 2 right now and show that one. Okay, so as soon as we start here, okay, let's click the green flag to reset everything to its starting position. Okay, yeah, so this is the actual starting position for ground 2. It hasn't moved yet because we haven't connected it to the code. So let's see how ground 2 moves. So now when I go move to the left or to the right, nothing's happening here. Hold it. It's visible? This only... I know this was working. Let's get another one working and see if that one goes for now. I'm going to hide this one again. Let's go to ground 3 and see how that one works. We'll make that visible. And so that one's on the bottom of the screen. And let's see if that one works properly. WS. All right. So maybe this only works when everything's visible on the screen for some reason. Because I was just tested this out before and it was all working on this screen a few minutes before the broadcast. So I'm pretty sure this should be working. So there's something going on here that... Alright, well, so once I connect all of them, it does work. I'm a little bit confused by how this works as well, guys. So what it's really doing, though, is blocking off all the different sides of the screen so that no matter where we move, there's always a screen that's going to be there. So when that first screen moves off and exposes the white, there's always going to be something visible underneath it as well, you can see. And so we have this infinite area that we can move across now using our different keys. My A key is making me move to the right, and my D key is making me move to the left. I think we should fix that before we do anything else. My down key is down, and my right key is, or my up key is up. So let's go and fix that before we do anything else. I'm just going to go back to my astronaut again. I must have entered the wrong numbers there. So let's do a -1 here and a +1 here and see if that makes a difference. Stop and restart the program. Now I'm going to use my A. Yeah, now I'm moving to the left. Now with my D, I'm moving to the right. Okay, we're good now. So you can see the basic movement in the game is all set up now. I can move. You can also hold down 2 keyboard keys at once and move on the diagonal. And because it's normalized, everything's going to work fine. If you're curious about this, we can actually remove the normalize and see how this works without normalizing the equation. So got to be careful how we do this, but I'm going to grab this by the word normalize. I'm going to pop all the code back in except for the normalize code. Now, I don't know if you're going to be able to detect this or not, but when I move on a diagonal, we should be moving a lot faster now because we're not normalizing. Whoa, that actually looks slower, eh? That's weird that it would move slower. So Jeffrey assured me that this would make the game perform better, but I'm not seeing it right now. It does. Yeah, it's much smoother when I put the normalize function in. I'm not even quite sure how some of this coding is working, guys. This is very complex stuff, as I was saying. Okay. So anyway, our movement's working nicely now, which is really great. So I didn't give you guys the code. I mean, I pre-packaged the code so you don't have to do it yourself. But so what's really happening here is just we're changing the offset of these things based on where our player is. So we're just taking our player and we're offsetting this. This one's going right in the middle, so it's going 0. The second one is being offset by 480 to the right. And the third one is being offset by 360, which is the size of the screen down at the bottom. And the ground 4 is probably going to do it at the top, right? Or this one's going to do it in both dimensions on a diagonal. So Jeffrey has set this up in such a way that all 4 of the ground things are overlapping. So you're only allowed to have a ground sprite that's the size of the screen. Scratch doesn't let you draw bigger than the screen. So we're going to take these 4 and basically overlap them so that they're so big that there's never any part that's exposed. Okay, so we're making some good progress here. Okay guys, so we got our character moving in this infinitely big world right now, which is really cool. You're going to notice that this weird problem we have with things having to move across different XY coordinates, it extends to everything else, including the bullet that we're making and the ammo box that we're going to set up on the screen that we have to run around and try and find, and also our enemies. They're all going to be moving around in this virtual world, which means that their ordinary XY coordinates don't really apply. If we tell them to go to a certain space on the screen, it's not really going to add up to where you see them on the screen, because imagine the screen is gigantic, like 5,000 pixels across. So where are they on this 5,000 pixel screen? XY coordinates, the normal ones, don't tell you that. So that's why we're doing this extra mathy kind of complex stuff here. We don't have time for much more today, but let's get our laser beam working. That sounds like a lot of fun. So, okay guys, so we've added a green flag here and a hide command, so that's telling our bullets to hide. And then we've added a when space key pressed, create clone of myself. This is not going to be in the final version of the game, guys. It's just there temporarily. We're going to put our shoot command in the astronaut tomorrow, and we're going to make it so that when you click the left clicker on your mouse, it's going to shoot. But for now, we just want to be able to test our bullets, so we're just going to create clones of them temporarily. Okay, so now what should we do when these clones are created? Let's grab a couple of blocks here. We'll go when I started the clone. And the first thing we're going to do is play a little sound. So let's go to our sound effects here. We'll go sounds. And we'll go start sound, and I've already downloaded a cool laser sound. So this isn't Scratch's laser sound. This is a sound I got from the website freesound.org. They've got a lot of great free sound assets there. Listen to this. It's a little bit different from the pew pew sound that's inside Scratch. So we're going to set that up. So now every time I shoot with my space key, I can hear that laser sound. And we're going to tell it to start changing costumes so that it looks like kind of wiggly. And I'll show you guys in a second what that wiggly graphic looks like. So let's go forever and then next costume. So we'll go to our looks menu and grab that next costume. Kids seem to have trouble finding this for some reason. It's like the 6th element down here and under looks, next costume. Okay, so when I maximize my screen here and hit the space bar, now my bullet's in the wrong place, of course, because it's right on top of the other one, so you can't really see the animation effect. Let's get it to just move a little bit. Just before it starts moving, we'll get it to move like 20 pixels. Now, this is not what you guys should code. I'm just trying to show you what the graphic looks like. So let's go maximize it. I'm just telling it so that it's not on top of it. So here's the difference between the static laser and the animated one. You can see that it looks quite cool once we get the animation into it. And you can play with those colors if you want and try different kind of laser effects. But I think that looks kind of neat. All right. Now, let's stop. I'm going to get rid of that move 20 steps because we don't actually want it to move. Well, we are going to move it in a second. I'm going to show you. We're going to use a clever trick to make our bullet come out of the gun properly. And it's going to be, I'll tell you when we get to it. Okay, so we need another when I started the clone. This particular block of code is just controlling the animation and sound of the laser beam, but now we need another one that actually controls its movement. So let's grab another when I started the clone. Right here. All right, so the first thing we want to do is show, because we're invisible when we get started. So let's go show. And then, so depending on what direction we're facing, the bullet's going to come out in a different direction, of course. So we have to get the bullet oriented in the same direction that we're facing. So let's go point in direction. It's one of our movement commands under motion. Point in direction. So we've used this before when we did one of our shooter games, maybe our space shooter game a few weeks ago. Remember that we can only put a single number into here, and we want this to be a variable. We want it to be pointing in the same direction that our astronaut is doing that. So we have to use a sensing block to do that. Well, let's go over to our senses, and we're going to use this thing called a reporter block that's super cool, and I've shown this to you guys a few times. So it's right here. It says backdrop number of stage. This is a confusing command, and it really confused me at first when I started using it, because I was looking to find like the direction of an object. But when I went to look in here for direction here on the left, it wasn't one of the choices. It was just a whole bunch of sprites here and other stuff, volume, backdrop name. The reason for that is because all the attributes have to do with the stage, and the stage doesn't have the same attributes as our sprites. So before we change this, we have to change the variable on the right here. We're going to change this to say the name of our laser, or the astronaut, right? So we're going to tell it astronaut. Whoa, that flipped me over. Where am I now? I don't even know how that happened. Okay, I think I'm oriented again. All right, so we want to tell it to face in the same direction as the astronaut. So now we have some different variables here. We're looking at the direction, and this will report back to you. Let's try clicking on it. So minus 47.4 is the number of degrees that the thing is pointing. So once we drop this in here, it'll change that number to whatever direction our astronaut is. We can test that right now if you're interested. So right now my astronaut is pointing up to the left, and when I click on this, he'll spin, or the laser will spin around and match where my player is. So let's try that again. So if I'm pointing down here, for example, whoa, let me, I really can't point down while the thing is moving, so this isn't really a good demo. Never mind. Anyway, trust me, once this block is in place here, your bullet will always be facing in the same direction that you are. All right, we also want his XY coordinates to start at where our astronaut is, so we're going to go to our motion blocks. We'll add go to. Now we're going to grab this block that says go to random position, because it lets you choose go to astronaut, and that'll get him right on top of the middle of the astronaut. Of course, we don't want the bullet coming out of the middle of the astronaut. We're going to use some tricks in a second to get it into the right place, but let's get it shooting first, and then we can get the other stuff going. So the first thing we're going to do, so we're going to do a bunch of stuff later. We're going to put it in the middle here, but right now let's get our bullet actually shooting, then we can modify it in a second. So let's grab a forever here. Now our bullet's moving at a speed of 20, so I'm going to go grab move 20 steps. I'm going to save my file if anyone's behind me here. Okay, move 20 steps. Now, change ghost effect by 50 is what it says here. We're going to create a ghost effect here in a second that is going to, I should probably add that right now, okay? So, It's complicated. What's going to happen here is our bullet is going to come out of our gun it's going to come out of the middle of our body, which we don't want. Later on, we're going to do some tricks to move the bullet around so it's actually positioned at the tip of our gun. While it's moving into position, it should only take a fraction of a second, but just to avoid any problems, we're going to make it basically invisible here. So let's do that right now. So we're going to go into our looks menu, and we're going to set the ghost effect. I'm going to grab this one here, down here, that says set color effect. I'm going to drag it in right on top of the forever loop. I'm going to change it to say ghost effect. Remember, I think it was yesterday, we used that ghost effect as 99, and that means that the bullet will still be able to collide with robots and stuff, even while it's getting positioned, but it will be basically invisible when it's at 99. Alright, and so back to our code here inside the forever loop. Now we're going to change the ghost effect by -50. And that will make it semi-transparent. And I believe we have this set up. I'm not quite sure what Jeffrey has coded in here. I don't think any of this stuff really matters. If he's saying if touching the edge, then make the bullet disappear, but we're never going to see the edge of the screen. You know what? I am just going to skip this part here, and we're just going to go into so let's do an if statement here. Sorry, I just finished this code last night, and I thought I'd looked over all of it, but this part doesn't... No, we don't want to do that. So change ghost effect, and we're going to go if touching edge. Yeah, so we're going to say if touching edge. So let's go to our senses. So what we're doing here is making the bullet disappear when it touches the edge of the screen. So we'll go touching edge. If touching edge, then we're going to delete the clone. There's a whole bunch of other stuff that makes the bullet slowly fade away, but the bullet's going to be hidden behind a black boundary, so I'm not quite sure why we did that. It might be left over from an earlier version of the game. I didn't notice this until just now. So we're going to go back to our control blocks and go delete this clone, and that will get rid of it. All right, let's give a little test here. Our bullet's not perfect yet, but we should at least be able to try it out. So I'm going to point in a direction, hit the space key. There we go. That looks pretty cool. You can barely see that animation because the bullet's moving so fast, but I still think it's kind of cool. Alright, good. So yeah, we didn't need that fade out code there. Wow, so I don't even know if we need these ghost effects in here. I'm going to get rid of this ghost effect, and I'm going to get rid of this ghost effect too, I think. I don't think we really need it. And we'll see if we run into troubles in a second here. So forever, if touching edge. So this is a much more straightforward bit of code here. Now we're going to do something tricky though. As I said, the problem right now is that we're shooting and the bullet's coming out of the middle of our bodies. I guess I could have changed the graphic around so that he was holding his gun like that instead of holding like that, but I'm not much of a graphic designer. So I am going to set it up so the bullet basically jumps out of the gun, turns, moves a little bit to the right, turns again, moves a little bit forward, and then shoots out of the gun, basically. So it's going to do. So the bullet's actually going to go like that, a little bit like a lightning bolt. I don't think it will be visible here. If it is, though, then we can fix that using that ghost effect by restoring it. But I want to see kind of what it looks like without that as well. So let's go try that right now. So I'm just going to tell my bullet to navigate around a little bit like a magic bullet. Those of you who are conspiracy theorists will know what I'm talking about. That's a pretty obscure reference. Most of you aren't going to get that. Okay, so we're going to get the bullet to immediately turn 90 degrees. So we're going to get it to turn right. And then we're going to get it to move 15 steps. I measured this out. This is how far the gun is away from us horizontally. And then we're going to get it to turn back So no matter what direction we're facing, this will work because we're using relative directions here. We're saying turn 90 degrees from where you are right now and then turn 90 degrees back again. So no matter which direction we're facing, these will still work. And you notice we're not changing the XY coordinates, we're just moving, and that will move us in the direction we're facing. And so now we can move up 10 steps, just move 10 steps. And now our bullet should be coming right out of the tip of our gun. Let's try it out. That's awesome. It might, we could even change that number a little bit. It looks like it's coming out of the bottom part of our gun. And so if we, let's change that number to maybe 12 and see if that looks better. So that's going to make it go a little bit higher before it shoots out. There we go. That looks much better to me. Could even go a little farther. Eh? Let's try 14 and see what that looks like. Maximize our screen. Hey, I think that's actually pretty darn good, guys. Wow. Okay. So, Jeffrey has added some more code here to normalize the bullet's movement and make it move. So the problem right now is when we're moving across the screen, if we're shooting our bullets, I don't know if it's going to be detectable to you guys, but if we start moving fast across the screen, it doesn't really look like it matters much, eh? He's got some code in here that's supposed to reorient it to the direction of the screen. I'm a little bit worried about moving too far away from what he suggested here, so I'm just going to add that. So we're going to grab a new function. I'm not sure this is going to change the game very much, but just to be safe, we're going to add one last thing, and then we'll be done for the day. So I'm going to go to my custom blocks. I'm going to grab this custom command here that Jeffrey created called move with map, and I'm going to put it right after the move 20 steps command here. And we have to fill up those bubbles with something, and that's going to be player X change and player Y change. And that is going to make sure that it's properly oriented to this bigger map. I don't know if that's really going to affect the gameplay very much, but it might affect like our ability to collide with stuff in the future. So just to be safe, I want to make sure that we code it the way he told us to. My son is like a hacker genius, by the way. You'll be able to meet him at some point. He was on the stream a couple of days ago, and I'm going to have him in as a guest sometime as well. I think you guys could really learn a lot from him. Anyone who takes part in our live coding sessions, like where this particular game was developed, will also know Jeffrey as well. Okay, so let's just give it one last test. Beautiful. It doesn't look any different to me. Oh, okay, so what's happening is I can actually see a difference here. Can you guys see the difference? So when I move, the bullet is actually, looks like it's moving at a diagonal. That's because it continues to move along a line here. So if I am standing on one of these white lines here and I shoot, and I'm shooting directly straight, like so, it's kind of hard to aim properly. The bullet should keep going in a straight line, but if I'm moving, the bullet will move with me if we don't adjust it that way. And I think that's what's going on here anyway. Okay, so we are pretty much wrapped up for today. So tomorrow we're going to bring our robots to life. They're going to have this cool kind of zombie kind of movement, and they're just going to try and follow you and touch you. And when you get touched, you're going to vaporize in a very cool fashion, and it's going to be really neat. That's going to take a long time. There's a lot of code in the robots, and that might take the whole session. Then after that, we're going to work on our flashlight beam and the ammo box. We have a limited amount of ammo in this game, so the goal is you want to keep moving in the game. So we absolutely have to keep things, encourage the player to not sit in the middle shooting at robots. And the way you do that is by limiting the amount of ammo. So when you run out of ammo, you got to go find the next ammo box, or you won't be able to fight robots anymore.